define a polynomial function with degree 2. This exercise type makes use of the Gaussian algorithm, but not directly. First, we will be given some information that we have to transform into mathematical information, and then we can apply the Gaussian algorithm. So first information will be, we have a polynomial, we look out for a polynomial function with a degree 2. Then we're able to write down the general term for the polynomial function. Second information will be, we have one point, which I'm going to introduce later. And third information is we have not only a point, but we only know that this point is a critical point, which means it's either a maximum or a minimum. So with these three informations, we will be able to calculate the specific polynomial function with the degree 2, with the power of 2. And this we are going to do with the Gaussian algorithm. This is always a quite nice way to solve this kind of problems, to solve problems where you have a lot of information, or you have, how to say, you have some information be given, you have also some variables, and you can define those variables through calculating the specific information with the Gaussian algorithm. So I think this is always a quite nice way of calculating. And of course, when you have fractions, it gets more complicated, but when you have a calculator, the fractions don't really matter, but you just have to know the basic procedure, and that I'm going to show you in the following video. How to define a polynomial function with a degree 2. This is a little bit tricky, but I'm going to show you how it works. So, we have been given an exercise which says, define a polynomial function with degree 2. So we know, first I'm going to list all information because it's important with exercises to think about all the information which is given. So first, as I said, polynomial function with degree 2. Second information we have been given is there is a point. The point is -2, 7. Third information, there is a critical point. So it is a maximum or a minimum at m -5 -2. So maximum or minimum at -5 -2. We have been given these three informations, and now we should calculate the function, a concrete function. So first of all, we are going to translate all this information into mathematical information. So the first mathematical information now is fx equals ax to the power of 2, since it's a polynomial function with degree 2. So plus bx plus c. This is a general polynomial function with degree 2. So later we are going to make it more specific. Second information, p minus 2, 7. So we can say f minus 2 equals 7. Third information, we can say, of course, this has to be a point also of the function. So f minus 5 equals -2. And we can also say f, so the first derivation, f minus 5, has to equal 0. What we could also say, but it doesn't really help us, is the second derivation of -5 does not equal 0, but it doesn't really help us. And what we also need actually later is the first derivation, because we have information here. So we are going just to calculate it quickly. F is 2ax plus b, right? Also very general, but it's okay like this. We make it more specific later. So first we have been given this information here, then we translated it into mathematical information, and now what we are going to do is we solve with a matrix. And the way we do this, I can also show you, is 1. What information do we have? We have actually the first information we can't really use in the matrix. So actually it starts here, 1, 2, 3. The informations we can translate into the matrix. So first equation, we can insert -2 into the function, which is then 4a minus 2b plus c. So the second information is this. Actually, almost the same thing. So we say -5 is 25a when you insert it. 25a minus 5b plus c, since c, actually, we can't do anything here. And 3, just a second, I forgot, equals 7 here and equals -2 here. So now it's better. And we have this information, so first iteration of -5 equals 0, so we know, okay, minus 10a plus b equals 0. Plus b equals 0. So we have this information, 3 informations, very mathematically expressed, and now we need a matrix, because I said I want to solve it with a matrix, right? 4 minus 2, 1, 7. 25 minus 5, 1 minus 2 minus 10, 1, 0, 0. Now that's a matrix. And now we can solve it, and we solve it with the Gaussian algorithm. So I try to make it, to simplify the matrix. And right, what you always want to get out of a matrix like this is 1, 0, 0 something, 0, 1, 0 something, 0, 0, 1 something. So that you can read the solution right away. So this would be x1 is x2 is and x3 is So you want to have these steps to be able to read the solution. So I start here with 3a and say, okay, we say, I say 2 times 3 plus 1. So I want to do something here. I want to get a 0 here. 2 times 3 plus 1. So set 3a. 2 times 3 is minus 20 plus 4 is minus 16. 1 times 2 is 2. 2 plus minus 2 is 0. 0. 2 times 0 is 0 plus 1 is 1. 2 times 0 plus 1 is 7. Then what else? What else can I do? Okay, here I try something. 2a, I say. Of course, this is always very subjective. I mean, you could also solve it very systematically, but it takes a lot more time. But if you have a look at what you can solve very easily, then of course you're faster. So, what can we say? We say 2 times 2 plus 5 times 3. 2 times 2, so you also want to do something here. 2 times 2 is minus 10. No, this doesn't really help us, right? But we say we want to solve something like here, because what you always also want to do is you want to attack like different positions, like 1, 2, 3, and you want to do something in front, something here, and something here. If you combine always the same rows, then you will end up calculating in a circle. So this is also a point. So calculating matrices is something you may also want to learn, or practice at least. It's 2 times 2, so we do something in the front here. So because we already did something here, 2 times 2 is 2 times 2 plus 5 times 3. 2 times 2 is so we have a 50 here plus 5 times 10, so we get a 0. 2 times 2 is minus 10 plus 5 is minus 5. 2 times 1 is 2. 2 plus nothing, because there's a 0, stays 2. Minus 2 times 2 is minus 4 plus 5. This, also nothing, stays minus 4. And now we can do something maybe here also with the first equation. And there we say 5 times 1 minus 2 times 2. So we want to do something here. We want to get a 0 here in the first row. So we say 5 times 1 minus 2 times 2. 5 times 1 is 20 minus 50 is minus 30. Minus 2 times 5 is minus 10. Minus 2 times 2 is plus 10. And put them together and end up with 0. Then 5 times 1 is 5 minus 2 times 2. 5 minus 2 is 3. 5 times 1 is 35 minus 2 times minus 2 is 4. 35 plus 4 is 39. So now what we did actually is create 2 more zeros here and here. So actually the last step, it didn't really help us a lot, but it's also no problem at all. I mean, if you think something will simplify, if you do it like this, then you can also do it, but always pay attention not to go around in circles when you calculate. So not always put together the same equations again and again, but try to always mix different equations. Like 1 and 2, 2 and 3, 3 and 1, right? So this is usually, if you do it like this, then you usually get forward in your calculation. So what I want to do now is I say I want to eliminate something. And what I want to eliminate is here at the end 3 I want to eliminate. So I say 1b is 1a minus 3a. 1b therefore is minus 30 minus 3 times 3a. Okay, this gets too complicated. Let's say minus 30 minus 3 times minus 16, and I end up with 18. 0 stays the same. 3 minus 3, 0. 39. 39 minus 7 times 3 is also 18. So what else can I do? Actually, this time I just want to write it again. Because the overview is then better, but it's also, as I said already, it's very subjective. If you feel better just doing one step per matrix, is also perfectly okay. Just make sure you don't make any mistakes. That's the most important point. Minus 16, 0, 1 minus this plus 7 actually. Okay. Then what else can we do? We do something here, 1c, which is divided by 18. 1b divided by 18, so we have 1c, 1, 0, 0, 1. Then what can you do? Okay, let's say 3b. What can we do here? So you say 3a. We want to eliminate more and more. And we say 3a plus 16, 1c. So I eliminate here. At the first position, I will create a 0. So as I just said, 3a plus 16 1c 3, I will end up with 3b. So as I said, 3a minus 16 plus 16 is 0. 0 and 0 stays 0. I have 1 plus 16 1c stays also 1. Here at the end I have 3a, which is plus 7, plus 16, 1c, 1c is 1, 16 plus 7 should be 23. 23. Then what else can we do? We can do something with the second row. We say 2b is 2a. Then we could do maybe something here. 2a minus 2 times 3b. So we eliminate the 2. So 2b is 2a minus 2 times 3b. So we have 2b, 0, stays 0, minus 5 minus 2 times 3b, 3b, there's a 0, so it stays minus 5. 2 minus 2 times 3b is a 0. 2a is minus 4, minus 46, minus 4. Okay, you can also maybe calculate in your head. It's, what did I say? 2a is minus 4, minus, there it is. That's 2 times 46. It's also negative, so 1 negative too much, so it's minus 50. Then we almost have it. Here we still see we have minus 5, minus 50, and so we should divide by minus 5 again, so we end up with a 1 in the second position, and then we know what the second variable is. So we say 2c is 2b divided by minus 5, and then we end up with 1c, which is 1, 0, 0, 1. 2c, which is 0, 1, 0, 10, and 3b, which is 0, 0, 1, 23. Now we can read it, it's gets a little bit messy at the end, so it's 1, 10, 23, and also in this case 1, 1, 1. This is, we have our steps, and then we can easily read the solution. So we can say A is 1, B is 10, C is 23. So it's very easy to read the solution now, right? It wouldn't make any difference if I had, like, if row 1 and row 3 were switched. I can also, because I can always switch the rows, so this is not a problem at all to get those nice steps right. I just need 1, 0, 0 in each line. 0, 1, 0, 0, 0, 1, this is okay, so that I know, okay, this variable is isolated and I know A is this, B here is this, C is this. And then, last step, I just need to write down the function, which then is, because I know the solution, you can see it here, and we also knew from the beginning here what A, B, and C, how to put them into the function, and then I can just write it down, fx is 1, because A is 1, right? Plus 10 x, and C is 23 plus 23. So that's the solution. It's actually not too difficult, but you saw, of course, calculating the matrix here, that's some point, which is a little bit complicated, and you have to pay a lot of attention, of course, with these calculations, not to make any mistake. I think the easiest part is to translate the information which is given into mathematical information and also then translate into the equations. That's the easy part, I would say, but then it gets more difficult. You have to solve it actually, and if you have a calculator like this, which can actually not calculate matrices, then you have to do it by hand. But it's doable. Just make sure you have enough practice so that you won't make any mistakes in the calculation. This is really the most important point, because people usually don't make mistakes here, also not here, to translate into mathematical information, to set up the equations. But where people usually make mistakes is in this calculation. You also see it gets a little bit messy. If you don't have a good structure, then you easily make mistakes. But in this case, I calculated correctly, no mistake at all, and you saw it's doable. This is how it works. Thanks for watching. Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheets.com.